So this tutorial is going to start to go through the transform tab in Rhino 5. What I've done, and I actually wanted to pay attention to a couple of things I've done here. One, I have the transform tab up here, and I've got a bunch of tools running. But you should pay attention that I've pulled out the layers tool and put that beneath there. That is possible. It took a little bit of massaging, but that way you can revert sort of back to the old Rhino 4 way of being able to look at the properties of an object and adjust the layers simultaneously without having to negotiate a bunch of different tabs, which I find kind of obnoxious. So the first thing we're going to do, we'll just move right through this. The move tool, obviously that's, we go through like that. The edit soft bodies, this is essentially taking curves and turning on the near snap and then allowing you to grab that as a knot and move that around, which is really handy if you guys are doing some massaging. There's copy tools, rotate tools, scaling tools, mirroring. You set the mirror axis and then it mirrors the geometry. The orient tool, that's actually kind of new, and I don't know that it's all that handy, but if we come in here, we rotate. The way that works is you set a reference point on the object and then you reference that same set of points on the geometry. And come here, left click, so we can go orient from there to there, and we want to orient that from that to that. And so we can start to connect objects. That is a little bit more handy as you're trying to maybe set something up for 3D printing or orienting, connecting things that you know should connect. The box edit tool, this is, I think, completely useless, but I'll show you what's in here. This enables you to scale, rotate, and reposition the geometry in here. If you really want you to do this, I recommend turning on the gumball edit, which gives you the ability to rotate, scale, and move those geometries with a lot more ease and sort of intelligently. The difference between the two is, one, you can program. The box edit tool is something you can type in numbers. If you know the scaling distance you need to adjust, you can start to do that from that edit menu, as you can see right in here. I gotta select the geometry for this. So we can come in here and we can scale that, and we can adjust the increment that actually operates at. Moving along, you can orient objects onto a surface. So we go here, select the base point, select the reference point, and then you can see how that's going to, it's connecting those references to those geometries. A lot of this you're going to end up probably spending more time doing 3D rotations, and you can orient perpendicular. I'll let you guys explore some of this stuff. But then we can also do arrays. This is handy if you want to do 1, 2, or 3-dimensional arrays. So 8 by 8 by 1. I'm not going to go a 3-dimensional array because it tends to slow down the machine. But we'll go, my geometry is pretty big, so we'll just set that to 20. And the geometry isn't created until you confirm that. So we can change the spacing. We'll put that up to 50. Okay, that looks what we want it to look like. Say we're building a really monotonous city. We can come in. Now each one of these is its own geometry. Okay, from there we can also create polar arrays. There's a center. We can do to have 20 objects divided among, and then you set the angle division. So we want only around 180 degrees. So it does it 180 degrees and places those geometries appropriately. And so then we can come in here, we can change the number of items, we can change that, we can rotate, no, yes, all that. As we look at some of these, we can project geometries onto the construction plane. So if we take this, this is sort of like a Make 2D. This is actually really more handy when you're getting things prepared for the laser cutter or the CNC mill, and you will have a bunch of geometries that are floating on top of each other in plan. So if we go ahead and come in here and say we have, I'm just going to create some quick curves here. And then, so as we start to look at this, you need to have geometry oriented for the CAM software to be very specific, but if we've been working in plan, this all looks fine and well, but then we actually start to explore the three-dimensional space that it occupies. You can see that there's a lot going on. Nothing's aligned properly in relation to itself. And so if we come in here, select these guys, we can orient to the construction plane, and by default it will not delete that, but it will make sure you're in perspective or plan if you want to orient onto the ground plane, whatever construction plane you're trying to get that to work in. Okay, and then we can adjust this accordingly if we're trying to get specific heights out of our material. We can set the XY coordinates and align objects. I found that to be not so useful. Some of the other guys that are a little bit more useful in here, I'm going to come out and grab this guy, and I'm just going to delete these. Selection tools in Rhino work in the same way that they do in AutoCAD. If you select from left to right, it's anything that's inside the window. If it's from right to left, it's anything touching that, and you can see that that's a dashed line instead of a box. And so we'll come in here, and I'm going to, some of the more fun transformation tools that you guys will get into, you can start the twist, and it's going to ask you for an axis. So we define the axis, and we go into plan, and we can set the angle, and then we can start to rotate that around, and it'll automatically rebuild the geometry with a new set of U and V subdivisions. Those are essentially X and Y equivalent coordinates for the surface itself, and so if you look at this, each one of these boxes is a U or a V. So if we want to calculate coordinates on the surface, we do that by U and V. And that'll come in handy more when we get into some more advanced modeling and scripting and stuff. We can bend geometries. I'm just going to see how complex I can make this. Select the objects to bend, and we can set an axis, and then we can bend that around, and again it rebuilds the geometry and makes that more complex. Be careful as you guys do this, particularly if you're doing this and wanting to 3D print. It will create a mess for you. Eventually these surfaces will rip and tear, and there'll be holes and things won't be 3D printable or meshable, and so you have problems with that. Flowing geometry along a curve, that's actually that also can be handy. If you do that, you need to pay attention to the length. So we check the length of this. It's 139.392 feet here. So I'll copy that. And if I draw a line point, I set that distance. That has implications because now if I want to take an object and I actually want them to remain in proportion to one another, the length of these geometries is the same. So I'm just going to I'll type in scale 1D. And we'll scale this. And so say we want to reflow this geometry along that geometry, so we can come in here, flow along curve. You select the base geometry that's defining it, and then you select the target geometry. And when you select those, you need to select those near the start point of each. So if I clicked on that, then I want it to flow along that, wherever you select that, it's going to orient that geometry. And then we get a nice little slug-looking guy, and you can see this is we're starting to create some pretty intense geometries, but that's what you want. And so we can start to do this. If you're not familiar with the taper tool, the symbol essentially is exactly what it looks like here. Again, this works very similarly to the twist command. We're going to come up, we set a taper axis, and then we set a taper dimension, and then it's going to taper towards that axis. Okay. Again, rebuilding that geometry. Smoothing out, I don't recommend using that all too much. Maybe we'll go through that a little bit more in some of the more advanced modeling stuff. And flowing along the surface works similarly to sort of flowing on a curve, and I'll let you explore some of that stuff on your own. The last tool I want to go through here is that this thing's useless. Don't use the move tool. If you want to slightly nudge things around, you can do it that way. Don't. Be precise. Alright, so we'll turn on the Cage Edit tool. This is going to give us a couple of different options in here. We want, generally, for what I use the bounding box. That's the space and you'll see it appear here in a second. We're going to use a coordinate system based on the world. You can also use a coordinate system that you define using the 3-point system here. Cage edit points, I would just generally leave this alone. It's going to give you a 4x4x4 box, so it'll give you a little bit more. And you'll see this is going to eventually basically look like the warp tool in Photoshop here in a second. And the region edit will make that relative global here. So to pull that on, what we can do here is we can start to grab these control points and start to massage our geometries around. And this is really nice if you're trying to do something where you're actually just trying to massage something, but you don't want to do a lot of really heavy deformations to it. So if you're just trying to sort of massage a geometry and you have a base geometry that you know that is essentially can be derived from, you can start to sculpt that using the Cage Edit tool. All right, and that's the transformation tab.